Hello, in this lecture we will find the radius of the small circle. In the drawing we have square ABCD, and we know that the size of one side of square ABCD is 8 units. AB equals to AC equals to DC equals to AD equals to 8 units, and inside the square we have two circles. This big circle has radius that equals to 2r, and the radius of the small circle equals to r, and we want to find out the radius of this small circle. So first of all we will do a construction, and before that we will define the center of the small circle as point P, and we will define the center of the big circle as point Q, and actually we will join together points A and P by a straight line. And we will define the touching point between the tangent AB to the small circle as point M. So MP is the radius of the small circle, small r, and we will draw the radius of the circle from point P to this tangent, we define the touching point between the radius to the tangent as point N, and we actually have a rule number one. Rule number one states that a tangent to a circle is perpendicular to the radius at the point of tangency. So I will read rule number one again. Rule number one states that the tangent to a circle is perpendicular to the radius at the point of tangency. So actually rule number 1 means that, for example, this tangent AM, is perpendicular to the radius at the point of tangency. The point of tangency of tangent AB is at point M. So at point M, the tangent to the circle is perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees, because a tangent to a circle is perpendicular to the radius at the launch point or at the point of tangency, and the point of tangency is actually point M. So at point M, the tangent is perpendicular to the radius, that is to say, this angle is 90 degrees and this angle is 90 degrees. And we also know that all the 4 angles of a square are right angles, they are equal to 90 degrees, so this angle will be equal to 90 degrees. And again, according to rule number 1, the tangent BC to the circle is perpendicular to the radius, to this radius at the point of tangency. We will define this point as point L. So at point L, the tangent BC is perpendicular to the radius. This is to say, this angle equals to 90 degrees. Okay? And so we have here in quadrilateral PLMB, this quadrilateral, we have 3 angles that are right angles, and we know that the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, and we have 3 angles that in total they are equal to 270 degrees. So in order to complete the sum of the angles to 360 degrees, this angle must be also a right angle, it equals to 90 degrees. So here actually we have quadrilateral with 4 right angles, and so if this shape is a rectangle, so any quadrilateral that has 4 right angles, it must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So in this rectangle PLMB, actually side PL equals to side MB. So, but we know that PL equals to the radius of the circle, so MB will be also equals to the radius of the small circles. That is to say, it equals to R. And we also, according to the rule that the opposite sides in a rectangle are equal to each other, so actually PM equals to LB, according to that rule. But we know that PM equals to R, so LB will be also equal to R. So we have here actually a rectangle with 4 sides that are equal to each other. So any rectangle that has 4 sides that are equal to each other, it becomes a square. So actually we have here a square. So PLMB is a square. All its sides are equal to each other. They are equal to R, the radius of the small circle. And in the next step, and also we know that at the point of tangency, point N, the tangent AM, this tangent AN is perpendicular to this radius at the point of tangency. That is to say, this angle is a right angle because of the fact that the tangent is perpendicular to the radius at the point of tangency. The point of tangency is N. So at point N, the tangent AN is perpendicular to the radius, according to rule number 1. So this angle equals 90 degrees. So in the next step, we will prove that the triangle A and P, the right triangle A and P, is perpendicular to the right triangle APM. Okay, but before that, I will present to you a new rule number 2. Rule number 2 states that if we have a circle and from external point of a circle we draw 2 tangents to that circle. Okay, so if from external point of a circle we draw 2 tangents to a circle, so if from external point to this circle, point P is external point, and from point P we draw 2 tangents to this circle. So the first tangent will be we will define the touching point between the tangent to the circle as point A, and then we will draw a second tangent to this circle. We will define the touching point between the circle and the tangent as point B. So if from external point of a circle we draw 2 tangents to a circle, then according to rule number 2, AP equals to BP. Okay, this is actually rule number 2. So we will continue to prove that those 2 right triangles can go into each other. Okay, so first of all, according to rule number 2, here we have point A, that is external point to this small circle, and from point A we have 2 tangents to the small circle. AM is tangent to the small circle at point M, and AN is tangent to the circle at point N. According to rule number 2, AN equals to AN, AN equals to AM. Because when you draw from external point of a circle two tangents to a circle, then those two tangents will be equal to each other. That is to say, AN equals to AM. AN equals to AM according to rule number 2. Okay. Again, AN equals to AM according to rule number 2. And PM equals to NP equals to the radius of the circle. PM equals to NP equals to the radius of the small circle. And we also have a common side. AP is a common side. It belongs to both right triangles, so AP equals to AP. It is a common side that belongs to both triangles. Okay? So we proved that all three sides of the right triangle AMP are correspondingly equal to all the three sides of triangle APN. Okay? So we actually proved that those two right triangles can go into each other according to side rule. Okay? So actually triangle APM, the right triangle APM, is congruent to the right triangle APN, this right triangle, according to side rule. Okay? I'll repeat again. The right triangle APM congruent, this is the sign of congruent to the right triangle APN according to side rule. Side rule. What is side rule? If you prove that all the sides of one triangle, if you prove that all the sides of one triangle are correspondingly equal to all the sides of the other triangle, then you prove that those two triangles can go into each other according to side rule. So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. According to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other according to side rule. Therefore, those two corresponding angles will be equal to each other. And if we define angle APM as alpha, then angle APN will be also equal to alpha because of the fact that those two angles are equal to each other. They are corresponding angles in congruent triangles. Therefore, they are equal to each other. So, we concluded that angle PAM equals to angle PAN, and both angles are equal to alpha according to our definition. Okay? Angle PAM equals to angle PAN, and both angles are equal to alpha according to our definition. So in the next step we will do a construction we join together points A and Q by a straight line. We will draw we know that the radius of the big circle equals to 2r. It is twice as long as the radius of the small circle. So we will draw the radius of the small circle at the touching point between the tangent and the circle. So we define the touching point between the tangent and the circle as point S, and according to rule number 1, we have tangent AS that is perpendicular to this circle. So this is the radius. We know that the tangent is perpendicular to the radius at the point of tangency, and the point of tangency of tangent AS is at point S. So at point S, the tangent AS is perpendicular to this radius. That is to say, this angle is a right angle, it equals to 90 degrees. And also, we have here the radius and the tangent AD, and we define this point as point F. So tangent AD is tangent to this circle at point N, so the point of tangency is point F. So the tangent AD is perpendicular to this radius at the point of tangency, to the point of tangency. So this angle equals to 90 degrees because of the fact that the tangent AD is perpendicular to this radius at the point of tangency. The point of tangency is F, so this tangent AD is perpendicular to this radius at point F. That is to say, this angle is 90 degrees and this angle is also equals to 90 degrees. And actually we will prove that those two right triangles can go into each other. Okay, exactly in the same way as we did for the small triangles, the small circle. We proved that those two triangles can go into each other, and in the same way we will prove that those two triangles can go into each other. So we focus on the right triangle ASQ, this right triangle, and triangle AQF, this right triangle, and we will prove that those two right triangles can go into each other. Okay, we know that AF equals to AS according to rule number 2. AF equals to AS according to rule number 2. I repeat again, AF equals to AS according to rule number 2. Also, we know that this is the radius of the big circle, it equals to 2r, and this is also the radius of this circle that also equals to 2r. So QS equals to FQ equals to the radius of the big circle that equals to 2r. Okay? Actually, it is given us the question that the radius of the big circle is 2r. So QF equals to FQ equals to 2R, and here we have a common side. AQ equals to AQ belongs to both the right triangles, so AQ equals to AQ. It's a common side that belongs to both right triangles. It is a common side. So we actually proved that the right triangle ASQ is congruent to the right triangle AQF according to side rule. All the sides of the right triangle AQF are corresponding equal to all the sides of the right triangle ASQ. Therefore, those two triangles can go into each other according to side rule. So I write it down. Triangle ASQ congruent to triangle AQF according to side rule. Okay. I'll repeat again. Triangle ASQ is congruent to triangle AQF according to side rule. So from the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. That is to say, angle SAQ is equal to angle FAQ, this angle, according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other. Therefore, these two corresponding angles will be equal to each other. And if we define angle SAQ as beta, then angle FAQ will be also equal to beta because of the fact that they are equal to each other. Okay? So, I will repeat again. Angle SAQ equals to angle FAQ according to the rule that corresponding angles in congruent triangles are equal to each other, and we define those two angles as beta, so they are both equal to beta. And we know that in a square we have 4 right angles, yes? So actually this is one angle out of 4 angles in triangle ABCD. In this triangle ABCD, this is one angle out of 4 angles, and every angle is equal to 90 degrees. So angle BAD, this angle equals to 90 degrees. Angle BAD equals to 90 degrees. Again, angle PAD equals to 90 degrees because of the fact that all the 4 angles in a square are equal to each other, and they are equal to 90 degrees, they are right angles. But what is the size of angle DAB, or okay, you can see it also as angle BAF. Okay, angle BAF, this angle actually consists of 4 angles. We know that angle BAF equals to 90 degrees, but it itself consists 4 angles. So this angle BAF that equals to 90 degrees it also equals to 2 alpha plus 2 beta. So angle, this angle that equals to 90 degrees, it actually equals to 2 alpha plus 2 beta, as you can see from the drawing. Again, this angle that equals to 90 degrees consists of 4 angles, 2 angles that are equal to alpha and 2 angles that are equal to beta. Okay, so 90 degrees equals to 2 alpha plus 2 beta. We will divide this equality by 2 and we will get that alpha plus beta equals to 45 degrees. Alpha plus beta equals to 45 degrees. So here we know that those two angles are equal to each other, therefore the tangents of those two angles will be also equal to each other, yes? So we can write down that tangents alpha plus beta equals to tangents 45 degrees. If two angles are equal to each other, the tangents of those two angles will be also equal to each other. It is a very simple rule. But what is the value of tangents 45 degrees? The value of tangents 45 degrees is actually 1. And so tangents alpha plus beta equals to 1. But actually we have trigonometric identity that for tangents alpha plus beta. The trigonometric identity for tangents alpha plus beta, it is actually tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta. This is trigonometric identity that we don't have to prove, but we can use it. We can use it in order to find out the radius of the small circle. So instead of tangents alpha plus beta, we will write down this expression, and so tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta according to this equality. Actually tangents alpha plus beta equals to 1, so this expression equals to 1. Okay, so this expression is actually tangents alpha plus beta according to the trigonometric identity, and we know that tangents alpha plus beta equals to 1. Okay, but we know that the size of side AB is actually 8 units. And we know that MB is the radius of the small circle, that is to say it equals to R. So if AB equals to R, then MB will be equal to AB minus MB. Again, AM will be equal to AB minus MB. Again, AM will be equal to AB minus MB. Okay, so again, AM equals to AB minus MB. Okay? AM equals to AB minus MB. AM equals to AB minus MB. AB is actually 8 units, and MB equals to the radius of the small circle. So in total we found out that AM equals to 8 minus R. So we will write here that AM equals to 8 minus R. So now we can calculate the value of tangents alpha. Tangents alpha in triangle, so again, we relate to triangle AMP. So in triangle AMP, tangents alpha equals to MP over AM. MP over AM. Again, in the right triangle AMP, we know that tangents alpha equals to AMP over AM. But what is the value of MP? MP or PM is the radius of the small circle, and AM, we already found out that AM equals to 8 minus R. So in total we got that tangents alpha equals to R over 8 minus R. Again, tangents alpha equals to R over 8 minus R. Okay. So we know that AD equals to 8 units because of the fact that all the sides in a square are equal to each other. They are all equals to 8, so AD also equals to 8 units. And what is the size of FD? So we will calculate what is the size of FD. Here we have 90 degrees because the tangent is perpendicular to the radius at the point of tangency. F is the point of tangency, therefore the tangent AF is perpendicular to this radius. That is to say, this angle equals to 90 degrees. So here we define the touching point between DC, the tangent DC to the circle, as point Z. Then we will join together points Q and Z by a straight line. This straight line QZ is actually the radius of the big circle, that is to say it equals to 2R, because when you draw from the point of the circle, you draw line segment from the center of the circle to a point of any point of the circle. It is the radius. It is defined as the radius of the circle. So, and the radius of the circle equals to 2R. So, from point Q, that is the center of the circle, we draw a segment line to point of the circle. So QZ, it is the radius of the big circle, that is to say it equals to 2R. And we know that the point of tangency is point Z, so according to rule number 1, the tangent DC is perpendicular to this radius at the point of tangency. This is to say this point equals to 90 degrees. Okay, this point also equals to 90 degrees because the tangent is perpendicular to this circle as the point of tangency, that is to say point Z, so this angle is 90 degrees. Okay, and we know that all the four angles of a square are equal to each other and are equal to 90 degrees. So this angle is one of the angles of square ABCD that it equals to 90 degrees. So we have here three angles. We have three right angles in quadrilateral FQZD. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. The sum of three right angles is 270 degrees. 90 degrees times 3 is 270 degrees. So the fourth angle must be equal to 90 degrees in order to complete the sum of the angles to 360 degrees. The sum of the angles in any quadrilateral is equal to 360 degrees, and we have three angles that in total are equal to 270 degrees, so the fourth angle must be equal to 90 degrees in order to complete the sum of the angles in quadrilateral FQZD to 360 degrees. This angle must be equal to 90 degrees. So here we have actually any quadrilateral that has four right angles, it must be at least rectangle. Okay, any quadrilateral that has four right angles, it must be at least rectangle. So actually quadrilateral FDZQ has four right angles, therefore it is at least rectangle. So what we know that in rectangle FDZQ side FQ equals to 2R and side ZQ equals to 2R also. And we know that the opposite sides of any rectangle are equal to each other. So FQ equals to DZ, but FQ equals to 2R, and so DZ must be equal also to 2R because the opposite sides of a rectangle are equal to each other. And we know that ZQ is equal to FD because FDZQ is a rectangle and the opposite sides of a rectangle are equal to each other, that is to say ZQ equals to FD. But ZQ equals to 2R, so FD must be also equal to 2R. So we actually found out that this shape is a square because it has four right angles and four sides that are equal to each other, so it is more than rectangle, it is actually a square. Okay, so quadrilateral FQZD is a square, and okay, so in the next step, so we actually know that FD equals to 2R and AD equals to 8 units. AD minus FD is AF. Again, what is the size of AF? It is AD minus FD. I will write it down. AF equals to AD minus FD. AD minus FD. Okay? AF equals to AD minus FD. Okay? AD minus FD is AF. So AF equals to AD is 8 units, and FD is 2R. So we found out that AF equals to 8 minus 2R. So we can write here that AF equals to 8 minus 2R. And FQ equals to 2R. So here we can calculate the value of tangents beta. Okay, tangents beta will be equal to R or FQ over AF. FQ over AF, it is the side that is in front of the angle over the side that is near the angle. That is to say FQ over AF. But FQ equals to 2R and AF equals to 8 minus R, so in total we found out that tangents beta equals to 2R over 8 minus R. Tangents beta equals to 2R over 8 minus 2R. Okay? We have the value of tangents beta, and we have already found out that tangents alpha equals to R over 8 minus R. Tangents alpha equals to R over 8 minus R. So I will write down this equality again. Tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta equals to 1. So I will write it again, and then we will substitute tangents alpha by R over 8 minus R, and we will substitute tangents beta in this equality by 2R over 8 minus 2R. Okay? So the equality is tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta equals to 1. That is the equality that we found out. Again, we will substitute tangents alpha by R over 8 minus R, and we will substitute tangents beta by 2R over 8 minus R, and in this way actually we will have one equation with one variable that is R, and R is exactly the variable that we are looking for. We want to find out the radius of the small circle that it is equal to R. Okay? So tangents alpha equals to R over 8 minus R. We have, and tangents beta equals to 2R over 8 minus 2R. So it is tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta. Tangents alpha is r over 8 minus r, and we will multiply it. We multiply it by, okay, tangents alpha we multiply it by tangents beta. That is actually 2r over 8 minus 2r, all equals to 1. Okay, so actually here we will write it in a new page. So here we will take a common factor. We get that 8 minus r times 8 minus 2r will be the common factor. So here we have r. So r must be multiplied by 8 minus r. So actually this expression is actually r over 8 minus r, because we have this expression is actually r minus 8 minus 2r, because 8 minus r will get cancelled. Okay, and we will add to it actually here it must be, we want to get the value of r minus 8 minus r over 8 minus r, so this is the expression. Here 8 minus 2r will get cancelled, and we will left only if r minus r over 8 minus r, and here we have 2r. We will multiply 2r by 8 minus r. So actually the second expression is actually 2r over 8 minus 2r, because here r minus 8 or 8 minus r will get cancelled. Okay, so actually this expression is actually equals to this expression, and then we will divide it by, here we will take a common factor. Instead of 1 we will write 8 minus r over 8 minus r times 8 minus 2r over 8 minus 2r, that is actually equals to 1, in order to have a common factor with this expression. So instead of r, we will write down 8 minus r over 8 minus r, and then we will write down 8 minus 2r over 8 minus 2r, so actually this expression is 1, because 8 minus r over 8 minus r is 1, and 8 minus 2r over 8 minus 2r is 1. So in total this expression equals to 1. In this way we will have a common factor with the second expression, with this expression. So here we have in the numerator 2r squared. 2r times r is 2r squared. So here actually this expression will get cancelled with this expression because it is actually exactly the same expression, 8 minus r times 8 minus 2r. So 8 minus r times 8 minus 2r over 8 minus 2r over times 8 minus 2r is actually equals to 1. So this expression will get cancelled with this expression because when we will divide this two expression one by the other, we will get 1. So 1 is actually, it means that this expression is cancelled because 1 is actually nothing, because when you multiply a number by 1, it will remain the same as it was before you multiply it by 1. Okay, so here we will move this expression to the denominator, and we will get that r times 8 minus 2r plus 2r times 8 minus r over 8 minus r times 8 minus 2r minus 2r squared equals to 1. So here we will cross multiply this expression, and we will get that r times 8 minus 2r plus 2r times 8 minus r equals to 8 minus r times 8 minus 2r minus 2r squared. So we cross multiply this expression and we got this expression. We will open the brackets in this expression and we will get that eight r minus 2r squared plus 16r minus 2r squared equals to 64 minus 16r minus 8r plus 2r squared minus 2r squared. Here plus 2r squared minus 2r squared will get cancelled, it equals to 0, and what left after we cancelled these expressions, here we have it is actually 8r, 8r times 8 is 8r. Okay, so here we have 8r plus 16r is 24r, and minus 2r squared is minus 4r squared equals to Here we have 64 minus 16r minus 8r is minus 24r. Okay, so we will add 4r squared to this equality, and we will get that 24r equals to 4r squared minus 24r plus 64. Okay. Here we will subtract 24r from this equality, and we will get that 4r squared minus 24r minus 24r is minus 48r plus 64 equals to 0. Here we have a quadratic equation. Okay, we will divide this quadratic equation by 4, and we will get that r squared minus 12r plus 16 equals to 0. Actually, the general equation for a quadratic equation, the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So this is the general equation of a quadratic equation, general formula for a quadratic equation, when a, b, and c are the coefficients of the quadratic equation, and the variable that we want to find out is x. And the solution to this quadratic equation is actually the following expression: x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. This is the solution for a quadratic equation. So, as I already told you, we are looking for the variable x, and in order to find out the value of the variable n, the value of the variable x, we have a special expression in order to find out the variable x, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out. Okay, so actually in our specific quadratic equation, the variable is r. The variable is r, and the coefficients of the quadratic equation are a equals to 1, b equals to minus 12, and c equals to 64. Okay, we have the coefficients of our specific quadratic equation, and we also know that the variable that we want to find out is actually the radius of the small circle. So all what that is left to do is to put these variables or the data inside this expression in order to find out the value of r. X equals to r, so r equals to minus b. B equals to minus 12, so minus 12 is plus 12, plus minus root of b squared. B equals to minus 12. Minus 12 squared is 144 minus 4 times ac. A is 1, so 4 times 1 is 4. And so here I made a mistake. It is actually C equals to 16, as you can see here. Here, this is the quadratic equation, so C equals to 16, okay? C is not 64, but 16, okay? So it is 4 times A times C. 4 times, or minus 4 times A is 1, so minus 4 times 1 is minus 4, minus 4 times 16 is minus 64, over 2 times A. 2 times A, 2 times 1 is 2. Okay, so we got that R equals to 12 plus minus 144 minus 64 is 80, so it is root 80 over 2. Okay. Okay, we have this solution. This is R will have two values. First of all, 80 is 4 times 20. Okay, so write it down. R equals to 12 plus minus. Instead of 80, I will write down 4 times 20 over 2. So R equals to 12 plus minus root of 4 is 2. 2 times root 20 over 2. So R equals to 12 over 2 is 6. 2 over 2 is 1. So in total we got that R equals to 6 plus minus root 20. 20 equals to 4 times 5. So I write it down. R equals to 6 plus minus root of, instead of 20, I will write down 4 times 5. 4 times 5 equals to 20. So we will get that R equals to 6 plus minus root of 4 is 2. So in the root we have only left with 5. So we have the radius of the small circle equals to 6 plus minus 2 times root 5. So we have here two solutions. The first solution is R equals to 6 plus 2 times root 5. This is the first solution, and the second solution is R equals to 6 plus minus R equals to 6 minus 2 times root 5. This is the second solution. But we actually know that the square has 4 sides that all are equal to 8 units. So the size of the square AB equals to BC equals to CD equals to AD equals to 8 units. Okay, it equals to 8 units. So because of the fact that the side of a square equals to 8 units, the radius of the small circle must be smaller than 8 because it is inside the square. If it will be more than 8 units, then it will be outside the square, but it is inside the square, so it must be less than 8 units. So R must be less than 8. units, because the small circle is inside the square and the side of the square is 8 units, so it must be less than 8 units in order to be inside the square. But here 6 plus 2 times root 5 is greater than 8 units. R equals to 6 plus 2 times root 5 is greater than 8 units. Therefore, this possible is not true. The solution is not correct because the radius is bigger than the side of the circle, and we left only with the answer that the radius of the circle equals to 6 minus 2 times root 5. Units. That is actually about 1.55 units. Okay, it is about 1.53 units or something like that. Okay, so we found out that the radius of the small circle equals to 6 minus 2 times root 3. Okay, so I check it again. We have root 5 times 2 so it is about 1 point, the radius of the small circle, it is about 1.53 units. Okay, and the radius of the big circle is twice as large as the small circle, so it will be about 3.06 units. Okay, so the answer to the question is that the radius of the small circle equals to 6 minus 2 times root 5 units. That is about 1.53 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this small circle, and inside we have here a square. Inside the square, and one side of this square equals to 8 units, and inside this square we have 2 circles. We have the small circle, and the radius of the small circle is r, and the radius of the big circle is twice as long as the radius of the small circle. It is equals to 2r, and we want to find out the size of r, of the value of r. This is the radius. We want to find out the size of the radius of the small circle, of the value of r. Okay, so first of all we made the construction. We join together points A and P. We draw these 2 radiuses, and we have rule number 1 that states that a tangent to a circle is perpendicular to the radius at the point of tangency. So we have here tangent AM, and the point of tangency is point M. So rule number 1 states that the tangent AM, or the point of tangency of tangent AM, is at point M, and according to rule number 1, the tangent AM is perpendicular to this radius at the point of tangency, that is to say, at point M, the tangent AM is perpendicular to this radius, that is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And the same thing is about tangent BC is tangent to the small circle at point N. Point L is the point of tangency, so the tangent BC is perpendicular to this radius at the point of tangency. This is to say this angle is 90 degrees and this angle is 90 degrees. The same thing is not here. Here it is 90 degrees because the tangent is perpendicular to this radius at the point of tangency, and actually we proved that those two right triangles can go into each other. Okay. We have also, we proved that those two triangles can go into each other, but before we do it, we have also rule number 2 that states that if you draw from an external point of a circle, if you draw two tangents to a circle, then those two tangents will be equal in their sizes. That is to say, AP equals to PB. Okay? Actually, point A is the point of tangency between the circle and the tangent PA, and point B is the point of tangency between the tangent PB and this circle. Okay, so AP equals to PB. This is actually rule number 2, and we continue to prove that those two right triangles can go into each other. So first of all, we know that AM equals to AM according to rule number 2. From the external point A, we have two tangents to this small circle. Okay? Tangent AM and tangent AN. So if from external point of a circle you draw two tangents to a circle, then they will be equal in their sizes. So AM equals to AM. AM equals to AN according to rule number 2. AM equals to AN according to rule number 2. And PM is the radius. Why? Because it exits from the center of the circle and touches the circle at point M. PN is also the radius because of the fact that it exits from the center of the circle and touches the circle at point N. So Pn is the radius and Np is also the radius, so Pm equals to Np equals to the radius of the small circle, and we also have here a common side. AP is a common side, it belongs to both right triangles. So AP equals to AP is a common side, so we actually proved that those two right triangles can go into each other according to side rule. What is side rule? Side rule states that if you have in one triangle, three sides of one triangle are corresponding equal to three sides of the other triangle, then the two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles will be equal to each other. That is to say, angle PAM equals to angle PAN, and if we define this angle as alpha, then this angle will be also equal to alpha because of the fact that they are equal to each other. So we found that those two angles are equal to alpha. Okay, then we also did a construction near the big circle. We join together points A and Q by a straight line. We draw here the radiuses of the big circle. Again, we have rule number 1. A n is tangent to the circle at point S. Point S is the point of tangency. Therefore, the tangent AN is perpendicular to this circle and to this radius at the point of tangency at point S. This is to say this angle equals to 90 degrees. And the same, according to the same rule, this angle also equals to 90 degrees, and this angle is also equal to 90 degrees. Okay, so we prove that those two right angles can go into each other. In the same way as we prove that those two right angles can go into each other. Actually, we have rule number 1, that rule number 2 that states that AS equals to AF, because of the fact that from external point of the big circle, that is to say from point A, we draw two tangents to this circle, to the big circle. So those two tangents will be equal to each other according to rule number 2. That is to say AS equals to AF, or AF equals to AS according to rule number 2. And we have QS is the radius of the circle, and QF is also the radius of this circle, so they are equal to each other. QS equals to FQ equals to 2R, that is the radius of the big circle, and we have a common side. AQ is a common side, it belongs to both triangles, so AQ equals to AQ is a common side, so we prove that all the three angles of triangle of the three sides of the triangle ASQ are corresponding equal to all the three sides of the right triangle, triangle AQF. Therefore, we prove that those two triangles can go into each other according to side rule. From the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles can go in triangles are equal to each other. That is to say, angle SAQ equals to angle FAQ equals to beta. If this angle equals to beta, this angle also will be equal to beta because of the fact that those two angles are equal to each other. Okay? So we found out that those two angles are equal to alpha and those two angles equal to beta. And we know that all the four angles of a square are equal to 90 degrees. So especially this angle BAF or BAD equals to 90 degrees. Angle BAD of the square ABCD equals to 90 degrees. But angle BAD or BAF that equals to 90 degrees consists of four angles, alpha, alpha, beta, and beta. So the sum of those four angles equals to 90 degrees. That is the size of angle BAD. Okay? So actually 90 degrees equals to 2 alpha plus 2 beta. It equals to 2 alpha plus 2 beta. Okay? And then we divided this equality by 2 and we got that alpha plus beta equals to 45 degrees. If alpha plus beta equals to 45 degrees, then tangents alpha plus beta will be equal to 45 degrees. Those two angles are equal to each other. Therefore, the tangents of those two angles will be also equal to each other. Very simple. Okay, so if alpha plus beta equals to 45 degrees, then tangents alpha plus beta will be equal to tangents 45 degrees. Okay? We know that tangents 45 degrees equals to 1. And we have trigonometric identity for tangents alpha plus beta. According to this trigonometric identity, tangents alpha plus beta equals to tangents alpha plus tangents beta over 1 times tangents alpha times tangents beta. tangent alpha times, okay, times tangent beta. So instead of tangent alpha plus beta, we will write this expression that equals to tangent alpha plus beta according to this trigonometric identity. Okay, and this expression will be equal to 1. Okay, so we wrote down this expression that actually equals to tangent alpha plus beta, and it equals to 1. According to what we have already found out, that tangent alpha plus beta equals to 1. So then we calculated the value of tangent alpha and tangent beta. What is tangent alpha? Here we have right triangle and the angle alpha. We know that AB equals to 8 units, MB equals to 1. So what is the size of AM? AM is actually equals to AB minus MB. That is to say, it equals to 8 units minus R. AM equals to 8 units minus R, and PM is the radius of the small circle. So we found out that actually the tangent alpha equals to PM over AM. PM is R, AM is 8 minus R. So in total, we got that tangent alpha equals to R over 8 minus R. R over 8 minus R. Okay, then we found out the value of tangent beta. But first of all, we calculated the size of FD. Here we draw radiuses of the big circle. Again, we have this radius and we have the tangent AD. The tangent AD is perpendicular to this radius at the point of tangency, that is to say point F. So this angle is 90 degrees. This angle is 90 degrees because it is the angle of a square that equals 90 degrees, and this angle is also 90 degrees according to rule number 1. So we found out actually, so we have 3 right angles, and the sum of the 3 right angles is 270 degrees. So the fourth angle must be equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees. So because of the fact that this quadrilateral has 4 right angles, it is at least rectangle. If not square, it must be a rectangle at least. Okay, but we also know that the opposite sides of a rectangle are equal to each other. So if FQ equals to 2R, then DZ must be also equal to 2R. And if ZQ equals to 2R, then the opposite side FD must be also equal to 2R. So we found out that a quadrilateral FDZQ is actually a square, and in this way we found that FD equals to 2R, and we know that AD equals to 8 units. So what is the size of AF? AF equals to AD minus FD. That is to say, it equals to 8 units minus 2R. Again, AF equals to AD, that is 8 units, minus FD, that is 2R. That is to say, AF equals to 8 minus 2R. And FQ is the radius of the big circle, that is to say, it equals to 2R. So what is the value of tangent beta? Tangent beta equals to 2R over 8 minus R. Tangent beta equals to 2R over 8 minus 2R. So we found out the values of tangent alpha and tangent beta. Therefore, we can actually substitute tangent alpha and tangent beta in this equality by the value that we found out. Okay, we found out the values of tangent alpha and tangent beta. We will substitute tangent alpha and tangent beta in this equality by the values that we found here. Okay, instead of tangents alpha, we write down r over 8 minus r, and instead of tangents beta, or we substitute the value of tangents beta by 2r over 8 minus 2r. Okay, so we did this here. Okay, we substitute the tangents alpha by r over 8 minus r, and we substitute the tangents beta by 2r over 8 minus 2r. Okay, we actually solved this simple equation because it is one equation with one variable that is r, and this is very simple to solve a equation that has only one variable that is actually r. Okay, we solve this equation. We add two roots to r, two possible answers for r, and the first root for r is actually r will be equal either to 6 plus 2 times root 5, or the second possibility is that r equals to 6 minus 2 times root 5. Okay, but we know that the size of the square, one side of the square ABCD is 8 units. So, and we know that the small circle is inside the square, so the radius of the circle must be less than 8 units because it is inside the square. Okay? And the size of one side of the square is 8 units, so it must be less than 8 units. So this possibility that r equals to 6 plus 2 times root 5, it is impossible because it is greater than 8 units. So according to this answer, then the circle itself is not inside the square but outside the square. So this possibility is not correct, and we left only with the possibility that the radius of the small circle equals to 6 minus 2 times root 5, that is actually about 1.53 units. Okay, so that is the answer to the question, that the radius of the small circle is equal either to 6 minus 2 times root 5 units, or it equals to about 1.53 units. Okay, thank you very much.